Welcome to Study Loop.
Okay, so we are given a spring of mass 1 kg with damping coefficient C as 10 and spring constant we have several values 10, 15, 20, 25 and 30, and initial condition is velocity is 1 meter per second from equilibrium point. Okay, and we need to graph for different values of K's with type of damping. Okay, so condition for the type of damping depends on value of C square minus 4mk. Okay, so if it is greater than 0, then we have overdamp. If it is equals to 0, critically damp, and if it is less than 0, then it is underdamp. Okay, so let's check. Since our mass is 1 and C is 10, which is fixed, so M is 1 and C is 10. So first let's calculate for K equals to 10. So for K equals to 10, we get C square, that is 10 square minus 4 times 1 times 10, so that is 100 minus 40, which is greater than 0. So this is overdamp, correct. So this is overdamp. Okay, now let's check second condition for K equals to 15. Okay, so this is 10 square minus 4 times 1 times 15, so this is 100 minus 15 4s are 60. So again this is greater than 0, so overdamp. Okay, so two functions for two values we have overdamp. Then for third, it is K equals to 20. So this is again 10 square minus 4 times 1 times 20. Now this is 100 minus 80. So again it is greater than 0. So we have overdamp. Great. Similarly, we can check for 25. Okay, so for this is again 10 square minus 4 times 1 times 25. So 100 minus 100, which is equals to 0. So this is critically damp. Okay, critical damping. Now let's find the last one. So for K equals to 30, we have 10 square minus 4 times 1 times 30, so that is 100 minus 120, which is less than 0, so this is underdamp. Okay, so we know the type of damping. Okay, so now we have to graph it. So the initial condition is velocity at time t equals to 0 is 1 meter per second, and it is starting from equilibrium point. Okay, so let's draw a graph. So first we'll have a vertical axis which represent displacement, and horizontal axis which represents time. Okay, fine. So now if we see for K equals to 10, graph is overdamp, right? So for overdamp and starting from equilibrium, it has some velocity, so it will rise, and it is overdamp, so it will come like this. Okay, so let me take another color. For K equals to 15, the gap is decreasing, so overdamping value will decrease, so we'll have something like this, so it will come down. Next, again for k equals to 20, again the gap has come down from 40 to 20. So for k equals to 20, it is again overdamped but with smaller value, right? So it will try to settle faster. Now for k equals to 25, so for k equals to 25, what we have is this critically damped or critical damping. So for such, it settles the fastest. Okay, so it will come down the fastest. And then we have underdamp. So for underdamp, it won't settle and it will keep on fluctuating. So let me draw this fluctuating one. Okay, and this settling depends on the coefficient, right? So it may be following this or following this, okay, whichever. So it will be for k equals to 30. So this is the qualitative graph, how it will look. You can find out the specific points by using calculator or by using the general formula. Thank you.